Let's practice simplifying with fractional exponents. So fraction exponents are rational exponents. They just represent different radicals. So the denominator represents what type of root we have. So this means that we have a square root. And then the top represents the exponent that we would apply. So since it's an exponent of 1, we don't need to worry about that. So now I can take the square root of 16 and the square root of x to the 4th. So that's going to become square root of 16 is 4. Right? If I divide my exponent here by the index of 2, right, I'm going to get a new power of 2, so I'm going to get x squared. So my final answer is going to be 4x squared. Okay, let's try another one. So here we have a cube root because we have a denominator of 3 in our fraction exponent. I'm just going to, whoops, that's not a straight line. Just going to draw some dividing lines in here so our work doesn't get so messy. So I'm going to have 27x to the 7th, and then it's going to be inside a cube root. So if I quick go off to the side here, 27 is equal to 3 times 9, and 9 is 3 times 3. So I can rewrite 27 as 3 cubed, and I'm going to rewrite x to the 7th as x to the 6th and x to the 1st. Because I have an index of 3, I want to be able to divide the exponents by 3. So now anything with an exponent that's divisible by 3 can come to the outside. So I'm going to bring those out. And then when I bring them out, I'm going to divide by the index of 3. Then I still have a cube root, and then I have an x left on the inside. So 3 over 3 is 1, and then 3 to the first power is 3. And then I'm going to get x squared, cube root of x as my final answer here. Okay, so the difference in this one is that we have a 3 in the top. So the 2 in the denominator tells us that we have a square root. So I have a square root, put the 2 there for us, of 4x to the 4th, y to the 9th, and then I'm going to put that whole thing in parentheses, and that top power is going to be the power on the outside. So I like to write it like that with the exponent on the outside because I think it's way easier to make things bigger to make them smaller before we make them bigger by applying an exponent. So on the inside, I'm going to apply that exponent. So the square root on the inside, the square root of 4 is 2. The square root of x to the 4th is x squared. I'm going to break up my y's to be y to the 8th and y to the 1st. I'm just going to try and save a little bit of room. I can even zoom in so I can write smaller. So then I can bring out y to the 8th, right, along with these two. And that's going to become y to the 4th. And then I still have square root of y. And then we're going to cube that. So I'm going to cube everything. So this 3 power is going to the 2 to the 1st. So it's going to everything on the inside. So we're going to get 2 cubed, x to the 6th. We're going to multiply those exponents, y to the 12th, and then the square root of y cubed. So 2 cubed is 8. I got x to the 6th, y to the 12th. Now since I have a y cubed on the inside, I can do y squared and y to the 1st, which means I can bring out another y. So we're going to get the original 8x to the 6th, y to the 12th, but I'm going to bring out that additional y. I have a square root of y left over, so overall I'm going to get 8x to the 8th, y to the 13th, times the square root of y. Okay, let's do a couple of more. So let's do some more with that top exponent. Okay, so let's do it this way. So let's do this one a little differently just because maybe that'll make more sense to you. I'm going to put my exponents here. And the first thing I'm going to do here, just to switch it up, is I'm going to apply this exponent of 5/3 to both parts. So I'm going to get 27 in x still, and now my exponents on those are going to be 5/3 and 5/3. So because they have a 3 in the denominator, that means that these are both cube roots. So I'm going to put the 5 on the outside here. And then here, I'm going to have a cube root of x, and I'm going to put the 5 on the inside there. And you're going to see why in a second. So for the numbers, I like to apply the exponents second. So for the 27, I don't want to raise 27 to the 5th power and then take the cube root because that seems awful. But for the x's, it's a little easier. So the cube root of 27 is 3. We saw that up above in example 10. Right, we broke down 27 there. So this is going to become 3 to the 5th power. And then here I have a cube root. I'm going to break x to the 5th up, so it's x cubed times x squared, because now I can bring out my x cubed since that's divisible by 3. So 3 to the 5th, if we use a calculator or an index chart or whatever you have there, 3 to the 5th is 243. And then when I bring out that x cubed, remember I'm going to divide it by the index of 3 that's on the outside here. And then I'm still going to have a cube root of x squared. So overall, I'm going to get 243x to the first, or just x, cube root of x squared as my final answer. So maybe that was a little bit of an easier way to think about it. So let's try that same method again in number 13. So we're going to apply the exponent that's on the outside to both parts of our inside. So that's going to give us 16 to the 3/4 power times x. Now let's go off to the side. We're going to do 2 over 1 times 3 over 4 for that exponent. So that's going to give me 6 over 4, which is going to reduce down to 3 over 2. So I'm going to get 3 over 2 here. So then here I have the 4th root of 16. I'm going to leave that cubed on the outside. And then here I have a square root of x cubed. Right? So these denominator numbers are just becoming our indexes, right? There's that invisible index of a 2 here. So now 16 is equal to 2 times 8, which is equal to 2 times 4, which is the same as 2 times 2. So 16 is 2 to the 4th. So that means the 4th root of 16 is equal to 2. So we're going to have 2 cubed in here. And then I have a square root of x cubed, so I'm going to break it into x squared and x to the first. 2 cubed is 8, and then I can bring out x squared here. So I'm going to have x squared. I'm going to divide by that index of 2. And then I still have an x left on the inside. So overall, I'm going to get 8x times the square root of 2 as my final answer.